The last time we had a video was on general things about balancing equations. So I said that I would go through and work this problem with you. Remember, this is a combustion reaction where we have an organic compound reacting with oxygen to form carbon dioxide and water. So this one has a fairly high number here, so that means that these numbers for the coefficients are actually going to be pretty large. So let's go ahead and go through the process just quickly. So we have 8 carbons here, 18 hydrogens here, 2 oxygens here, 1 carbon, 2 oxygens here, 2 hydrogen, 1 oxygen here. So remember, the first thing we always do on a combustion reaction is come over here and multiply our waters by 2 so that we will get a even number of oxygens on the right hand side or on this product side. Next, we balance our hydrogens, so we have 18 over here, we have 4 over here. I can't multiply 4 by anything to make it 18, so I look for the lowest common multiple, which would be 36. So I'll need to come over here and multiply this one by 9, which means I multiply the oxygen also by 9 on this side. That gives us 36 hydrogens, 18 oxygens. Over here, I need to multiply by 2, so that's going to give us 16 carbons and 36 hydrogens. So now our hydrogens are balanced. The next thing we want to do is balance our carbon. So I have 16 here, but only 1 here, so I'm going to multiply this by 16, which also multiplies this oxygen by 16. So that gives us 32 oxygens here. We're going to add these 2 oxygens together, so that's a total of 50 oxygens total on the right hand side or on the product side. So I need to come over here and multiply this one by 25 to make it have 15 oxygens on the reactant side. So I have 16 carbons, 36 hydrogens, 50 oxygens, 32 and 18, 50 oxygens. So what I multiplied here, I multiplied this one by 2, multiply this one by 25, so you can see I get a double-digit coefficient here. I multiplied this one by 16, again a double-digit coefficient. And then here we multiplied by 9, but also by 2 to start with, so that's going to be 18. So the larger this number is, the larger your coefficients are going to be on the oxygen, carbon dioxide, and water. Now there's more of these to practice, but I'm going to skip over these for now, and we're going to look at doing the same exact thing, but starting with words instead of with the formulas. So this is where you're going to have to know how to write your formulas for various substances. So let's go down to number 3. Well, let's look at number 2 first real quick. Ammonia is a common name for NH3, so this is a formula that you should learn for ammonia. If we were naming it as a covalent compound, we would call it nitrogen trihydride, but that's just the common name, so it's expected that you would know that one. So we'll go ahead and do this one here first. Now remember, a lot of our gases are diatomic, which means that they require having 2 of that particular element to make it stable. So just as a quick reminder, our diatomic molecules that we have talked about are going to be hydrogen, and then starting at number 7 on the periodic table would be nitrogen, and you kind of make a 7 on the table, so you'd have nitrogen, you have oxygen, you have fluorine, and then you go down the table, so you have chlorine, bromine, and iodine. And there's 7 of these, so it makes it kind of easy. So if you start at number 7 on the periodic table, then once you get here, you kind of make a 7 on the table. And then hydrogen's kind of the only lone ranger that's kind of off to the left. All right, knowing that, then if I'm writing this down, if it says nitrogen and it's by itself, we know that that's got to be the diatomic form of nitrogen. And it's being reacted with hydrogen, which is also by itself, so it would be in its diatomic form. And then we're producing ammonia, which is NH3. Fix that H, it's pretty bad. Once you get to this step, then this is the same as the exact things that we did earlier. All you got to do is balance. So just kind of quickly, we're balancing this one. We have 2 nitrogens. We have 2 hydrogens. We have 1 nitrogen, 3 hydrogens. I have 2 nitrogen here, 1 here, so I'm going to multiply this by 2, which also multiplies the hydrogen by 2, giving us a total of 6. I have 2 hydrogens here, 6 here. I'm going to multiply this one by 3. So now I'm balanced. I've got 2 nitrogens on both sides, 6 hydrogens on both sides. I didn't multiply this one by anything, so I put the 1. Multiply this one by 3, multiply this one by 2. So the trick on this one mainly is being able to write your formulas correctly. So let's look at the third one. It says aluminum bromide. So aluminum, remember, is one of those 3 elements that we memorized the charge for. Aluminum is always a +3. Bromine is in the halogen group, or the group 7A. It's a -1. So if aluminum is +3 and bromine is -1, I'm going to need a 3 on my bromine to balance that formula. Then I'm adding it to chlorine. Since chlorine's by itself, it's going to be one of these that's up here, this diatomic, so it's going to be a Cl2. And it says yield, so that's where our arrow goes. And then we have aluminum, again, that has a +3 charge. Chloride is chlorine, so it's in the group 7A also, so that's a -1. So this would have a 3. And then we add on our bromine. Bromine by itself, again, is diatomic. So this would be our initial setup for this particular equation. And then we would have to go in and balance. So if we go in and balance, we have 1 aluminum, 3 bromines, 2 chlorines here. On this side we have 1 aluminum, 3 chlorines, 2 bromine. Our aluminums are balanced. We have 3 bromines, but only 2 here. Again, since you can't multiply 2 by a whole number and make it 3, we got to look for the lowest common multiple. So I'd have to multiply this one by 3 to make it 6. Then I'd have to come back over here and multiply this one by 2 to make it 6. Since this aluminum is attached to this bromine, it also gets multiplied by the 2. So that messed up our balance of our aluminum. So now we can go and fix that and put our 2 here with our aluminum, which also affects this chlorine. Now we have 6 chlorines on this side. We'd have to multiply this one by 3 to make it 6 chlorines. So now we have everything balanced. 2 aluminums on both sides, 6 bromines on both sides, 6 chlorines on both sides. Pull up whatever we multiplied by. So there's a 2 here, a 3 here, a 2 here, a 3 here. So the hardest thing on this one mainly is writing the correct formulas. So there's several you can practice on here. If there's any you want me to go over with you, just send me an email. I'll be glad to. So the last thing I want to go over in this particular session is the types of chemical reactions that we're going to be looking at. Now there's a lot of types. These are the main ones that we talk about in this particular course. The first one is called a synthesis reaction, but some books will call it a composition reaction, some will call it a combination reaction. But basically on this one, you're going to start off with some kind of small substances. So you can have like an element plus an element, and you'll make a compound. Or it could be an element and a diatomic molecule and a compound. So what we did earlier with the ammonia, where we had our nitrogen and reacted it with our hydrogen to make our ammonia, this would be a synthesis reaction. We're taking 2 smaller things and making something more complex. You're not going to necessarily know how to write all the reactions for synthesis reactions unless they give you all the substances. Decomposition reactions are just the opposite of synthesis reactions. So if I start off with a compound of some sort, and I break it down into simpler forms, or its elements, then that would be a decomposition reaction. So if I just reverse the reaction we had a minute ago and start off with the ammonia, and I break it down into the nitrogen and the hydrogen, then that would be a form of a decomposition reaction. Now, I'm not balancing these, you can see, but you can balance them once you get them written out. Again, decomposition reactions are not always real straightforward. So there are, if you're writing some of these, you may have to get some help on the different types that you might run across. A single displacement, or some books will call it a single replacement reaction, involves taking, and I'm going to just do a general down here at the bottom, you're going to take some kind of an element, react it with a compound, and you're going to produce a new separate element and a new compound. And where I'm putting element here, it could also be a diatomic molecule, like chlorine or bromine or some of these, okay, that you'll run across. There's two different forms of this. So this one is a little more tricky because you have to look and see what your single substance is, or your more simple substance is, as far as what your substances on the product side will be. Now remember, we talked about some of these before. A cation, remember, is a positive ion. Typically, these are going to be metals, or they could be metalloids. If you're doing a cationic single replacement, you're going to have something, let's say that we have sodium, and we want to react it with a compound, so we'll react it, let's say, with calcium chloride. Then I have an element that's reacting with a compound. So what I need to do in this particular case is I want to